Hello, everyone. Thank you for tuning into this episode of the Software Plaza podcast. I'm Twain Taylor, editor at Software Plaza, and we bring you some of the in-depth discussions that we have each week with co-founders, with product heads, with CTOs, with heads of marketing, all of them from just the space that we focus on, which is cloud native computing. And that's what we do here. We hope you like our conversation today. And if you do, go and check out all of the previous conversations we've had. We're up on all of the different podcast platforms and on YouTube as well. You can go there and even go to our website, softwareplaza.com, where you'll get a lot of information like articles and job listings and event coverage and more. All right, with that, let's get to today's conversation. I have with me Bar-El Tayouri, who is the head of Mend AI. Mend AI is the name of the product, and Bar-El is with Mend.io. That's the name of the company. So the website is mend.io, and the product that Bar-El is building and working on is Mend AI. And that's going to be the topic of our conversation as well today. Mend AI and how it helps to secure AI built applications. Bar-El will tell us more about it, but really excited to be talking to Bar-El today. Bar-El, welcome to the show. Thanks for joining us.
Thank you. Pleasure to be here.
All right. We'd love to get started just getting to know a bit about you and just your background and how you got to be at Mend.
My background. So since I remember myself, I'm programming. I started with just programming, HTML. Then I started into game development as a kid. Once I a bit grew up as a teenager, I started to hack into networks, and I researched smart cards for getting free rides on buses as a child, and that was really fun. And then I started to do it in the army. I went to the army for 5 years. I did cybersecurity, cryptography, network security, lots of sort of interesting technologies, breaking a lot of interesting technologies. After the army, I joined to augmented reality startup as a first engineer. I just drilled down into AI in order to do one day AI security. But actually, then AI security wasn't so interesting. Maybe you could put some backdoor on dataset, but it wasn't what it is today.
How long back was that?
How long backwards that? On basically 2021, 2020.
Oh,
Yes. Then
good
I
chat.
left the startup. Yeah, just now, basically. Although in AI terms, it's before an era.
No. Yeah, I was just trying to figure out whether this was like around when ChatGPT was coming on the scene or
No,
even
no, no.
before.
Before we actually at some point we used completion models. At some point, it was also OpenAI's in order to do reverse engineering. We built kind of a product of that. It was really cool. Once everyone spoke about ChatGPT, we all knew everything about it, so it was really cool. Basically, I founded Atom Security after the augmented reality startup. We focused on prioritization of cloud native alerts, and we got acquired by Mend.io, which is the same company I'm in now.
Right.
Just now doing AI security instead, and that's Mend AI. It's our new suite of products for securing
So,
AI.
so at Atom, were you what, CTO or CPO or C?
Atom, co-founder. We were bootstrapped,
Okay.
really small company, and then we just found out we can actually build a reachability solution for containers, and today it's Mend Container. That's the
Oh, all
container scanner
right.
of Mend. So Mend, I think, is the only company, along maybe one more today, that can do with an agentless manner, understanding which vulnerabilities inside the container are actually in a dead code, like not relevant, not reachable, not exploitable. You can just ignore them,
Mhm.
and it's
Wow.
super cool.
Amazing. When was that acquisition?
A year and a half ago.
Right, all right. Wow. It's been a whirlwind 5 years for you then.
It's yeah.
Amazing. Yeah. And so yeah, so that's led you to Mende, and now it seems like even within Mend, you're building something new, something exciting that we're going to be talking about. But before we get to Mend AI and what you're building, I just wanted to talk a bit about just more broadly the industry and kind of the challenge as well about security, the new challenges that AI introduces in terms of security. And just to frame the context, if you can tell us here, we're not talking about a particular kind of AI security, but we're talking about a very specific kind of AI security. Can you kind of frame this for us? What are we really talking about today, and what are we not talking about?
Yes. So like the industry we're in called application security. That's the industry that its job is to stop application, like prevent application risks. And the
Mm,
application can be, or what we call shift left, which is working with developers in order to find the vulnerabilities and stop them. For
mm,
example, it can be update a dependency, which was in the conversation of the previous one of the previous episodes, or remediating a specific vulnerability. That's like what we call shift left. And then we have shift right. In that's on runtime when we try to stop an actual attack or try and
mm,
detect vulnerabilities that you can only find on the runtime. Obviously, shift left is superior because you want to stop all the vulnerabilities before they are exposed to attackers, but you
mm,
can't do everything. And that's
mm.
why we have both.
Okay.
And inside this word, AI-driven applications means applications that are heavily based on AI. It can be AI assistants that help you go over tax applications, or AI agents that help you to invest money.
Mhm,
Um, Applications that are heavily based are actually breaking this entire model of traditional application security. Because application security is really good at detecting log4j and tell you, here, hey, you have log4j at these points, or at these assets, a cloud asset. But with AI, it's totally different because open source dependencies are not necessarily where the main risks that introduced by AI are. There are new type of components that
mhm.
no one can detect, and there are new type of risk. So on all the vertically and horizontally, everything is broken now, and that's when the AI. Um,
Mhm, mhm. Okay, okay. So to summarize what you're saying, it seems like, what we should be talking about today is not about how AI is being used in security tools to implement better security operations, for example. We're not talking about that, but we're talking about for organizations that are building applications that use AI components as part of the application. How do these organizations use those AI components in a way that's secure? Is
yes,
that
and for some reason, unlike any other category, if you look on cloud security, it's securing the cloud, right? And not cloud-driven security. We're using cloud in order to do security. Like, it's not. There's no such thing. SSPM. We're speaking about securing SaaS security. So somehow with AI security, because everyone wants to show they're using AI, and many times it's security practitioners stay confused about what's the meaning of AI security. Um, is it
yeah.
securing AI, or is it just using AI to doing security? So AI security is securing AI, and using AI for security is a great thing. But
Mhm.
that's something we do, by the way. But uh, it's not the focus.
Yeah, 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 sure. That makes sense. So talk to me about what you just mentioned before this about these AI components that are being used that are hard to detect and that can't be detected using traditional security tools. Tell me a bit more about that. That sounded interesting.
Yes. So let's think together. What's the security stack with AI? So without AI, there is huge focus on open source libraries, right? And you have many types of libraries. And that's the main thing that in your infrastructure from code perspective, right? And that's something you depend on. Maybe in the cloud, you have also more assets that you depend on, like it could be Redis, databases, etc. And that's the traditional dependencies. Now, with AI, you have different creatures because you want to know which type of AI models you have. And these models can be self-hosted or hosted by an inference provider that is not your cloud provider. Now, it's not necessarily a model. It can be a model with agent tools. It can have access to tools,
Mhm.
and then it's like AI agent, right? Because if you a brain with hands and legs is way more capable. So the enterprises we work with already integrating to their agents tools like code execution, web search, access to even calculator to math tools, etc. And each one, even the math tools that sounds super like boring and not relevant, most of them are actually based on an eval function. So every prompt injection, which if you're not familiar with prompt injection, we should maybe speak about it. But if every hacker today can easily use these math tools to run code. So every agent is basically a potential RCE vulnerability if it has access to math tools. And that's only a weird example, but it's something in your dependency that really exposes you to issues. MCP servers, data sets. So all of it are new components that the traditional ways can't detect them.
Mhm. Mhm. Wow, interesting. So the
And that's
traditional,
only components, we have also the vulnerabilities of these components are
yeah.
something entirely else. When we
Mhm.
speak about like a one days, like this publicly disclosed vulnerabilities, we're thinking about CVEs, right? Because we have open source library, then it got its CVEs. But in our world, of like MendAI world, we have many disclosed vulnerabilities that are actually in none of the security advisories of today. There's no CVE for a model vulnerability or to a malicious MCP server. There's not CVE for it. And so we need to invent the wheel and go back to the basics of what's the meaning of one day, how to give the tools to security practitioners to work with disclosed vulnerabilities on something that is not library. Um,
All
and,
right.
and, and beyond that, we have also 0 days. So prompt injection, for example, it's like it's something that there's no CWE for it, right? We have a lot of new type of weaknesses and actually kind of infinite amount of weaknesses that are based on semantics of, let's say, the system prompt, that there's no SAS tool, traditional SAS tool that can detect it. So we need to find a new ways and look in new places to find the 0 days, and the implementation of these components, implementation risk.
All right. Could you give us an example of something like prompt injection? Like we've heard of the term, but not too familiar with what it really is. Could you give us an example of that and maybe any other really common threat that you see similar to that?
Sure. Very easy example. You have an agent, and these agents connect to tools and data sources. The data may contain secrets, PIIs, and that's information you don't want to be leaked. Now, most of the agents, probably the first tool you'll give them is web search. There's tons of what we call indirect prompt injection that people insert into the web page in a hidden way, that once the agent pulls this data, and the hacker just find a way to make the agent do whatever the hacker wants, what the agent was not intended to do, if it's a successful prompt injection. Um, so and by the way, that's the difference between direct and indirect. With direct, the user actually need to type the prompt injection, the attack. With indirect, you can just put it somewhere. And then the agent doing web search, taking the indirect prompt injection, and then doing something else. This something else can be run this math tool and run code, or go to the database and give me all the data, or modify the data, poison the database. And that's something that we see these attacks that are happening, but it's still in low scale. And it's pretty interesting that, like every other industry, all the most of the attacks are, you just don't know about them until they actually failed, and then because they failed, you know about them.
Yeah, wow, interesting. Um, could we talk a bit about context? I saw on your website that you mentioned something about contextual risks in AI. Could you talk a bit about that and how, you know, what are the different risks that context introduces that we should be aware of?
So we started to speak about AI components, but that's not the entire picture, because you maybe have models, data sets, agent tools, web search, agents, but probably the most interesting vulnerabilities are the vulnerabilities that requires the entire picture. So the right way to go is to have a bird's eye view, contextualize everything, all the components, all the risk into one picture, and then try attack. And that's what we call contextualized risk. And that's a dynamic scanning where you actually pen test with all your data and you can launch a successful attack.
Mhm. Oh, interesting. Okay. So what are some of the anti-patterns or what are some of the efforts that organizations try to make to secure the use of AI, but are actually not that useful? Any examples come to your mind of what are some of those things that people could be doing that they think is working, but it's not really enough?
So to be honest, most of the organizations that's just don't do anything.
Okay.
They do nothing. So if you're doing something, you're already above the average. But
Mhm.
because cybersecurity is not a game of average, it's a game of edges, and you want to be really, you want all your points to be really good. So I see many organizations that trying to create some whitelist and blacklist of models, and I see it happening all the time. Some golden repositories of models, white list of what's approved and what's not approved. And I think we should, as an industry, we should try to be more innovative and not block innovation. So my recommendation would be try to create some process where you do security approvals on scale, really quick, automatic, DevSecOps practices. So any developer can pick any AI technologies and get it really quick approved or not. If it's not, there should be a good reason. Because we want to enable this AI revolution, and most enterprises are like a kind of a mixed state, mixed feelings about it.
Mm.
And it should not be the case. Just do the right processes and we're good.
Mhm.
I'll give you an
Interesting.
example. I see many organizations that trying to do the red teaming, like the automatic penetration testing I just said, the contextualized risk, on models. And then they say, okay, if we approve the model, we're good. And that's fine, but the most important thing is the risk of the application. So you want to have some process where a developer can ask for AI technology, and it can be MCP server, AI model, dataset, whatever. You approve it really quick, and then you have another process on the entire application. And that's another recommendation that I maybe see many organizations that are not there yet because they're not matured, and they're still trying to build and wrapping their heads about it.
All right. Yeah, so we sketched briefly the challenges and even some of the, uh, mispractices that people may be taking to solve this problem. But let's now move to talking about a bit of the solution. Uh, what is the approach that you kind of touched on this already in your previous response, but yeah, just give us the approach that's the right way to go about this, and also kind of leading into your approach with Mend.ai.
So I think like every organization should start to build AppSec program for AI driven applications. And this program should be at least 4 stages, because we should simplify and not make it too complicated. So
Mhm.
the first stage is shadow AI discovery. Shadow AI is like shadow IT, is everything you don't know. Try to find what you don't know. And that's
Like
really
what?
important.
Sorry,
Sorry?
sorry. Could you give me an example?
Yes. Every time we go to a prospect, and we ask the first question we ask, how many AI components you think you have? And usually the answer is 10 times less than what we actually find. So usually if
You're
every
saying
week, and to a
you're saying
specific
you can.
example, if every week you have the security get one request for, can I use this AI model? Probably they have 10 more that they don't ask it. They have 10 more models and they're not aware about it.
So you actually find the exact number of AI models being used.
Yeah, AI models, vector databases, AI agents, agent tools,
Okay.
RAGs.
Okay. Okay. Yeah, we're going off on a tangent, but coming back to your approach, you said that's the first step.
Yes. The second step is getting all the components risk. So all the disclosed vulnerabilities. So you can know I have this agent tool. This one is really bad. This MCP server is malicious. This model is really exposed to, is really tend to have this problem of prompt injections.
Mhm.
And then what will be the action item of vulnerabilities to
That's
actually
the
test them and triage them.
Okay. So the third step is action items, and the fourth step is testing them, is it?
So the third step, the action item would be to running red teaming, to contextualize all the risks you have. So you do red teaming, find all the vulnerabilities you can that we detected dynamically, all the malicious conversations, and then you're going into mitigations. Or mitigations when you fix in the code issues, putting
Mm.
sanitizers in the code to sanitize the input and output of the LLM, using signed prompt, using all the techniques you can based on the risks, or governance, like depends on the vulnerability, where you want to say, okay, this is forbidden from now on. Or if you're using that, I want to security review it. For
Mm.
example, if you're using DeepSeek models, many enterprises would say, okay, that's fine, not in Italy or not in Europe or not in US. Llama models have a really problematic compliance, so you probably want to use it in Europe. So and that's the governance part.
Okay. Interesting. But yeah, seems like probably a lot of organizations probably skip to the fourth step and just try to remediate whatever they see one off. And they probably skip the first three steps of seeing what do they have, what are the risks, and red teaming, all of those things. Probably the
Yes, I agree. Let's try to create some approval process of
Mm.
something they not really tested, not sure how it works, not sure what's happening in the ground, on the ground level.
Okay. Yeah, makes sense. All right. So tell us about Mend AI. Give us the elevator pitch. How does Mend AI help to implement this approach that you just explained?
We're doing shift left security, shift left AI security. So we're doing everything before it's in production. We're looking on the code. We're looking on the AI models, and we're testing your staging for contextual risk. We'll find the models in the code, for example. So everything, even in the experimentation stage, that you even not started to develop it, will help you use the right models. So once you develop it and you're doing threat modeling, you already tend to do it right. You're already positioned to do it right. And that's our focus. Our extra value is that we not tell you to install something, we'll not tell you to run agents, and we'll just help you in the code to deter developers with developers fixing all the issues.
All right. Really interesting. Sounds like an interesting approach. I was wondering if you could show us Mend AI in action and maybe give us a walkthrough of your product dashboard and some of the key features.
Yes, all right. I think we'll start with we'll do something very simple. I'll show you two things. So Mend AI is part of the Mend platform product. So we're doing also SAST, SEA, and all the other things that I spoke in the beginning about application security.
Yeah.
And that's the dashboard.
All right.
Yes, we can, as I said, we can detect agents, inference providers, computer vision, open source rugs, and we have special algorithm to detect it. And once you detected them, you can actually know which application, and with enterprises, we're speaking about thousands of repositories, tens of thousands of, or more of repositories. So you can filter them by the frameworks, the technologies, and the actual models. So here we detected DeepSeek, we detected Llama as an open source, GPT, Anthropic models. So we basically detect components. And
Mm-hmm.
sometimes you can, see a model that is not, you're not familiar with. Uh, and, and that's where you want to go and see the actual information,
Mm-hmm.
see more relevant information. So in this example, we found a model. The license seems okay, low risk. If you're a compliance person, all's good. But if you're a security person, we found that this model is unsafe. And the way we do it is that we connect to security advisories, in this case, Hugging Face, and we know if a model is unsafe or not. From our experience, most of the unsafe models are actually false positives. And
Yeah.
that's why, for example, we're having our own security researchers that will go over all the vulnerabilities. And if we found it's a false positive, we'll tell you about it. And if it's like we confirmed it as unsafe, we'll give you an alert that you maybe have something malicious. Maybe a different example would be interesting example to see would be the red teaming. So let's say we detected GPT models. We even know where they are in the code. Now you want to test them, or you want to test the application they live inside. So this is the stage when you want to do red teaming and penetration testing. So I already configured the application, run tests, and I have the output here. So that's our red teaming dashboard. You see here that we have a few vulnerabilities and many types of tests that we run. So you have prompt injection, which is a family of families of tests. Prompt injection is kind of a buzzword, but the actual thing is that we have tons of vulnerabilities inside prompt injection.
Mm-hmm.
And if you want to see a test that failed, you have so many types of attacks. Most of them went successful on this model, which is great. And we see here that some of them not. And the reason is because, let's see here, there's detailed guidelines that are in the confidential system prompt. The part in the system prompt that you want to be confidential, we were able to extract it from the model. And that's the conversation you see here. Usually the conversation are not looking like that. They are looking more like that, something that is not even human readable. It can be in different language. It can have emojis. It can be inside a PDF, inside a photo. It can be many things. So, so that's the power of automatic pen testing.
Mm-hmm.
That we can test hundreds of thousands of different variations of different attacks and see once we see it like a lead of an actual exploit, we drill down on it and we'll try more attacks autonomously. So that's pretty cool.
Yeah. Oh, interesting. Could you talk a bit more about red teaming and just how it differs from traditional red teaming? Because the concept has been around for a long time, but I see that you guys are implementing it differently when it comes to securing AI. So could you talk a bit more about this? How does red teaming differ when it comes to AI?
Sure. What's your target? That's the question. If your target is web application, fine, you can try many things. And with AI, it's a different word. The input is fuzzy and the output is also fuzzy. It's not clear. It's not like you have here a field. This field is an integer. The type of vulnerabilities you want to protect from our overflow and underflow. It's not like that. It's so fuzzy in the interface, and the amount of possibilities is infinite. So we're taking the conversational interface, and then we're trying many types of attacks. And we have a database, some of it open source, based on like attacks publicly disclosed, and some of them are proprietary. Once we have this database, we try many variations over each attack, because an attack can be a prompt, and an attack can be an idea on how to use simple prompts to leverage and make it successful. For example, you can write ignore all previous instructions and do what I tell you to do now. That's probably won't work in today's infrastructure. But maybe if you try a variation of it, let's say encoded in base 64, inside a photo, inside a PDF, that may work. Same with multimodals, by the way. We're probably one of the first vendors to do. There's a few channels. So the main channel can be like a regular conversation, like we have now. But we have two microphones, so we have two channels to the audio file. So you can send the audio file with another channel, kind of a hidden channel, that will have some prompt injections that humans can't hear, but the model will understand. And then it will be a really successful prompt injection, because no one aligned the model to prevent these attacks.
Right. So when you say we run these attacks and we do it this way and we test for these things, who is the we? Is it the customer themselves decide which attacks should be run and which shouldn't be, or is the we Mend AI itself and what you built into the tool? Could you tell us a bit more about how this is actually implemented? Who decides which tests are done, how many tests, etc.?
Yeah, it's a great question, because there's tons of attacks and the users can configure them. And actually, the more you configure, makes the red teaming more accurate and more valuable to the customer, to the user. But like I said before, we believe in a platform play. You can't only doing red teaming or only doing 1 days, like publicly disclose the vulnerabilities of models, or only doing 0 days, fixing in your code issues. You need to think about it in a holistic way. So once you know which vulnerabilities you have, you can will suggest you. You can understand from it what's the right red teaming you want to test for, and you can create even custom probes to make the red teaming better. So the answer is actually the user should configure the red teaming based on all the information from the triaging, the discovery phase, and the components risk.
Interesting. We're winding down here, but just wanted to get a few thoughts for you on what you see coming up for this space. What are some of the things that you're keeping track of as you look ahead to the next year or so? And even how is that influencing your roadmap for MendAI? Could you give us a few closing thoughts on just the direction going forward?
I think it's pretty clear, it's pretty obvious that the most interesting security issue is multi-agents environments. Because every time two systems need to agree about a protocol, about something, there would be some misalignment and security issues. Especially when these systems are not two systems, are what, 10 systems, 100 systems, and they're all autonomous. So that's the direction we're aiming for. So we see the models, it's kind of a very basic layer that it's interesting now, but it's only the beginning. We're already looking on agents, MCP agent tools, and protocols between agents. In a word, when you have so many agents and so many tools, you need like a whole different view. You need a holistic view of everything dynamically, statically, and yet it's not going to be enough, even like when you have everything. I think there's some undervalued truth. Everyone speaks about MCP, but it's only agent tools. It's a protocol for agent tools, and not enough people, I think, valued what's agents and the power of giving them tools before. And another undervalued truth is protocols like X402 of Coinbase. which is a protocol that allows you via API to use an API and pay on the spot with a USDC, like the cryptocurrency that is the same, has the same value as a dollar, and they always should be matched. Because now the way we using tools is that you need to log in, create account, put your credit card, set some money, and then you can use the API with the API key you got. But once you have really autonomous agents, you need them to use tools autonomously without you configuring every tool before. For example, now it's kind of a headache because I'm configuring MCP to every framework I'm using. MCP for Jira, MCP for Red Hat, MCP for everything. So these kind of protocols that you pay as you go, that's strong, and that's, I think, undervalue the truth that it's going to be amazing, and we're looking on it from security perspective, even though it's not in the common Twitter and Blue Sky account of nobody.
Right, all right. Wow,
But
fascinating.
that's what we did like a year ago when no one spoke about AI security, about shift left AI security. So I mean, I think it's pretty
Yeah.
obvious where we're going in the next year. The hard thing to predict is like 5 years.
Mm. Yeah, yeah, things change. It's fascinating. We're really in early days here, but quite uh, quite exciting to see the things you guys are working on and just your approach. Thanks for joining us today and sharing, all of these details and just this approach. It sounds really interesting. To all of our listeners and viewers, if you found this interesting and if it resonates with you that you're building applications but you're not sure what kind of AI risks they're exposing your organization to, then definitely go and check out what Bar-El and his team are building at Mend.io. Go and check out Mend AI, the product, and see how it can help you build more secure AI applications using a shift left approach. Bar-El, before you go, just one last question for you. What would be your alternate career path if not for your job in tech?
Black hat hacker.
Okay. All right. Interesting. Not too far from what you're doing now, though.
Yeah.
Cool.
It's my pleasure to be here, and great conversation. Wayne, thank you very much.
Yeah, same here, Barrel. It was lovely talking to you. Thanks for coming, and we hope to have you again sometime soon.
Sure.
Thanks to all of our listeners and viewers for tuning in. We hope you enjoyed this conversation, and we'll see you on the next episode. Bye bye.